Okay, we've been spending a little bit of time here the last several days looking at the quadratic equations, the parabolas that they graph. As a matter of fact, that's what all of Unit 9 was about, and the beginning part of Unit 10 has been about as well. Okay, over the last few days, we've seen several different ways that we can come up with information about the quadratic equations and the parabolas. Like the activity yesterday, we were looking at the equations, we were looking at their solutions, we were looking at their graphs, we were looking in the table to find points. There's a lot of ways to come up with information and solutions for the quadratic equations. Okay. However, there is a little bit more advanced way of doing this. And as a matter of fact, a lot of people do tend to favor this particular method because it works for all quadratic equations. It's not a matter of which ones might work or which ones are better to look at a graph or to look at a table or to look at the equation. It's not even a question of any of that. Okay, the quadratic formula applies for any quadratic equation. That's what we're going to be doing today. So as we've seen in recent days, there's many different methods for discovering solutions to quadratic equations. What we're going to see today is that there is one method that will work for any quadratic equation. The only real catch or drawback to this particular method is the formula looks awful. Okay, you may have even seen it as you've been looking around your formula charts over the years. Okay, and basically, okay, what we're dealing with is quadratics. Okay, we've seen this little generic formula or this generic equation before. Okay, this is what our calculator kicks out to us. We started to see that at the end of Unit 9. I told y'all, by the way, the equation we've been working with is kind of the dumbed down version of it. The calculator gives us the full one. And the full equation is ax squared plus bx plus c equals 0. And a and b and c are just some numbers, okay, that get plugged in there. Okay, but using those numbers, this whatever this number A is, whatever this number B is, whatever that number C is, if we take it and we plug it into this thing, this will tell us exactly what the value for x is for any quadratic equation. Okay, like I said, it does look quite nasty, and you may have seen it, looking around on your formula charts before. It is a formula that's provided for us, which is nice. Okay, it's already a bad enough formula without us having to memorize it. And when you get to Algebra 2, you'll work a whole lot more with this formula, and you might possibly even be required to memorize it once you get there. Okay, but for now, it's provided for us. They're going to hand it to us on our formula charts. So all we have to do is know how to plug into it and get a number out of it. Okay, so it's not as bad as it looks type of a formula, and it does look awful. Okay, but to put this thing into plain English, okay, or at least into math English, x equals, and that's what we've been working on, how to come up with the values for x, okay, the independent values. X equals the negative of the number b. Okay, anybody we've seen this notation before, plus or minus? Okay, it basically means there's two math problems going on there, whatever plus whatever and whatever minus whatever. Okay, so this is actually going to give us two different values. So we got the negative of the value b plus or minus the square root of the value b squared minus 4 is a constant. It's always going to be there. It's part of the formula. That will multiply times the value a and then multiply times the value c. And that b squared minus 4ac is all underneath that radical. That actually has a bigger meaning, and we'll talk about that here in the next couple of classes a little bit more. But anyway, that entire numerator then gets divided by 2 is part of the formula. It's built in there. 2 times the value a. So if you take those three values, a and b and c, and plug them in everywhere that you have and find an a and a b and a c out of the quadratic formula, this formula will hand you the values for x that solve the equation. Okay. So it's a pretty easy thing. It's awful looking. A lot of people just look at it and go, whoa, that's too complicated. I'm not doing that formula. I'd rather do some of the other stuff we've been doing. Okay, and that's fine. That's your option. You can do that. But we are going to learn how to do the quadratic formula. When it comes down to end of course test time or, maybe semester final time, whatever, if you have a particular method you like better than this, then use that method. Okay, but we're going to learn all the different methods and then you can pick what you like later on. Okay, so let's have a look at how questions are going to work with the quadratic formula. Okay, here is a basic quadratic equation. X squared plus 2x minus 2 equals 0. Now, I didn't really say it on the last slide, but I'll say it now. Okay, you notice how everything on this equation is on one side of the equal sign. Okay, that's important. The quadratic equation is going to need that. Okay, so we've been seeing some equations here lately where it's got some junk on the left and it's got some junk on the right, and we've seen that we can even work with it, even when it's spread apart by graphing it two different lines and then comparing the intersections. But when it comes down to the quadratic formula, we're not going to have stuff on the left and stuff on the right. It'll either all be on the left or all be on the right. That's the way we're going to need it. And if it's not that way, you're going to have to make it so. Okay, you're going to have to move some things around so it can all be on the left or all be on the right. Okay, so everything's already isolated on the left. That's good. Okay, it's a quadratic. We know it's quadratic because it has x squared. Okay, x squared. When you recognize that you have a quadratic equation, then your brain needs to go, oh, quadratic equation, I can use the quadratic formula. Okay, so what I want you to do, and this is just a basic strategy, anytime you use any formula off of the formula chart for any reason, whether it's finding surface area or volume or slope of a line or the quadratic formula like we're doing today, I want you to go to the formula chart, get your formula off the formula chart, and write it down on your paper. Okay, and that includes like today's homework. There's 8 questions on today's homework. The very first thing I want you to do for every single question is write down the quadratic formula. Okay, just get into the habit of writing the formula down. We don't want to start trying to plug in things mentally, get the formula off the formula chart, plug in numbers in our head, and then write stuff down on the test. That's where we make mistakes. Okay, we're just not good enough to do that many steps all at once. So we're going to write the formula down on our paper just like I've done right here. And yeah, it's a big nasty formula. It's going to take a moment to write it down, but just get in the habit of doing it. Anytime you need a formula, write it down. Okay, now all we have to do is identify the values. What is A? What is B? And what is C? We'll have a look at your problem. Okay, what number is A? Well, where do you find A? Okay, in the quadratic equation. Okay, where do you find A? It's ax squared plus bx plus c. Okay, so we look for A in front of x squared. What's in front of x squared? Just 1, right? There's nothing out there, so it's just a 1. So in this case, A is 1. Okay. What's B? Positive 2. Okay, right? B is the coefficient of x to the first, so there it is. And what's C? Negative 2, right? Remember the sign belongs to the value that follows it. Okay, so A is the coefficient of x squared. B is the coefficient of x to the first, and C is the constant. Okay, just a number. Okay, so we got 1, positive 2, and negative 2. That's just a connect the dots puzzle. Okay, we've got this big nasty formula that calls for all these A, B, and C values. Well, we've got the numbers that go along with A, B, and C. Plug them in. Okay, the formula says x equals. Okay, fine. The formula says negative. Okay, fine. The formula says B. Well, instead of B, we're going to plug in a positive 2. The formula says plus or minus, so we'll leave that there. The formula says square root, we'll leave that there. The formula calls for B. Well, once again, B is 2. We'll plug it in. The formula says that needs to be squared, so we'll square it. The formula says minus, so we'll subtract. Formula says 4, so we'll leave that. And then the formula says A. Okay, fine. We'll take A, which is 1, and we'll plug it in right there. And then we'll also multiply that times C, which our C value is -2. So we'll plug that in. The formula says to take all of that and divide it by 2 times the value A, which is, in this case, is 1. We're just plugging in numbers. Okay. After that, it just becomes a big pile of algebraic steps for us to follow and figure out what numbers these are. And remember, it is two numbers because in the numerator, we've got -2 plus whatever's going on with that radical. And we also have -2 minus whatever's going on with that radical. Okay, now let's just clean this mess up. Okay, now that we've got it all the way down to the algebra, now we're just worried about, please excuse my dear Aunt Sally. Okay, well, one of the things that's going to have to be a problem here is we've got all this junk underneath the radical. Okay, that needs to be simplified as much as possible, hopefully all the way down, before the radical does anything to those numbers. Okay, so that's where I'm worried about first. Okay, so underneath the radical, what would you want to do first underneath the radical? What's got to be tended to first inside of there? You got a power in there, right? Got an exponent? Okay, please excuse my dear Aunt Sally. So we need to worry about that exponent in there. So we're going to take care of this 2 squared, okay, which is obviously 4. And we've got a big pile of multiplication over here on the right. And then finally, we'll worry about the subtraction that's in the middle there. Okay, so what I did is I did go ahead and I did the 2 squared, which was 4. On the right side of that subtraction problem, I did the 4 times 1 times -2, which was -8. Okay. Um, don't lose that minus sign. Remember this little guy right here, 4 minus -8. Okay, that is, don't lose that minus sign. It's part of the formula. Okay, but that double negative, what's that going to be right there? 4 minus -8. What happens when you get back-to-back minus signs like that? They cancel each other out, right? Minus negative is the same thing as plus positive. Okay, so what is this number under here? 4 minus -8. Come on, people. Let's participate a little bit. I'm not asking questions because I'm curious what the answer is. I need y'all to know what the answer is. It's 12. Okay, 4 minus -8, same thing as 4 plus 8, which is 12. Now we got this big ugly thing right here. Okay. Now, in Algebra 2, when it comes around to it, you may be required to leave this in terms of radicals, so we'll worry about how to simplify the radical, how to reduce that fraction. Okay, but for Algebra 1, all I'm really concerned about is that you can get to a number from here. Okay, so once you get down to this point, okay, then I just want you to go to the calculator and let's find out what on earth this value actually is. Okay, well, in the numerator, okay, and I'm going to open up some parentheses because I'm going to put all this into one line. So I want the calculator to understand what's in the numerator, and then I'm going to want it to understand what's in the denominator so it doesn't do anything crazy to my order of operations. In the numerator, I've got -2, and I'm going to get the smaller of the two values first. So I'm going to do the minus part of that plus and minus. -2 minus the square root of 12. Okay. Um, hang on a second. I This calculator's kind of strange. There we go. Okay, so there's the numerator, -2 minus the square root of 12. And then that is going to be divided by our denominator, in this case, is just a 2, because it was 2 times 1. So all we have is a 2 down there. Okay, we ask the calculator what this value is, and we get this number, -2.73. Okay. Now, if you're a little bit more calculator savvy, what you can do is just hit second enter. That gets you the previous entry back. Okay, and you can simply go back in there and change that minus to a plus. If I can get my calculator to cooperate. Change that minus to a plus, because that's the only difference between the plus or minus is that sign right there. enter it again, and I get a 0.73 value. These are the two solutions, okay, that make this problem work. Okay, 0.73 and negative 2.73. Actually, I should have written those in reverse order. Usually write the smaller one first and then the larger one. But those are the two values. And I use the curly braces. Remember, we use the curly braces. That means that our answer is that we have, in this case, more than one answer. And here they are. This is not a coordinate. It's not a place in a graph where we go and can put a point. This is just a location on the x-axis. This is another location on the x-axis. Okay, but those are the two values that solve that problem that we just worked. Okay, it's really all it is, taking the quadratic formula and plugging in those values over and over again. Okay, now I don't expect that you probably have a good grasp on it from one problem, so let's look at another one. Use the quadratic formula to solve 3 plus 5x squared minus 2x. Okay. Now the quadratic formula solves any quadratic equation. Is this a quadratic equation? Yeah. How do you know if it's quadratic or not? It's got x squared in it, exactly. Okay. Now, the one thing that we did say is that unlike our problems that we've kind of been playing around with yesterday and the day before, where it was okay if we had stuff on both sides of the equal sign, quadratic formula is not going to allow that. Okay, so right now we got junk on the left, we got junk on the right. That's no good. Okay, so we need to either move everything to the left or everything to the right. Typically, the best strategy to get into the habit of doing is to move everything where x squared can be positive. Okay, you're going to run into some more stuff as you go higher and higher in mathematics where the lead term of a problem is going to want to be positive. Well, our lead term is our highest exponent, x squared. Okay, so what I'm going to do is I'm going to move everything either to the left so that x squared can be positive or to the right so x squared can be positive. We'll look into the problem right now. X squared is already positive, so we'd like it to stay where it is. Everything else needs to join x squared. Okay, so x squared's on the left. It's already positive, so that's good. That means 2x, okay, in my book is coming to the left. Okay, well, how am I going to move that 2x from the right side over to the left side? Subtract it, right? It's just a positive 2x. In order to move it, we're going to do the opposite of it, which is minus 2x. And whatever we do to one side, we have to do to the other side to keep the equal sign balanced. Okay. I'm also going to reorganize the problem so that it's in that quadratic format. I'm going to put the x squareds out front. So I'm going to put 5x squareds out front. The next thing would be the x to the first terms, and here they came, minus 2x's. And then the constant was positive 3, and that emptied out the right side of the problem. Okay, so there is nothing over there on the right, equals 0. Okay, well, A equals, B equals, C equals. What is A this time? It's a 5, yep. B, what's B equal? Negative 2, exactly. Remember that the sign belongs to the value that follows it. And C this time will be 3. Okay, so this would be where we go to our formula chart or to our notes or whatever, and we get our quadratic formula and bring it to the paper. X equals big fraction, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, and then we just plug in our numbers. Okay, the formula says x equals big fraction, negative, we need to plug in b. The formula says plus or minus. We've got a square root. We've got a b we've got to plug in, squared minus 4. We've got an a we've got to plug in. We've got a c we've got to plug in. And the formula says 2 and an a we've got to plug in. Okay, so, and you don't have to do all this with the parentheses and stuff like that. I'm just kind of giving us an opportunity to fill in the blanks. Okay, all we have to do is just follow along. The formula said b. Let's go get b and let's plug it in. Formula said B again, get B and plug it in. Formula said A, get A and plug it in. Formula said C, get C and plug it in. And then in the denominator, the formula had another A, so get A and plug it in. Okay. Let's see if we can clean this mess up a little bit. What do we have? X equals what? Let's see what we can do. Actually, let's move this down a little bit. Getting a little close. Okay. Negative of -2. What's that? +2, right? So there's no reason to have double negative. Just write 2. Plus or minus square root. Okay, let's see if we can clean this up. What's -2 squared? +4, right? -2 times -2 is +4. Let's see what we have going on over here. 4 times 5, 20. And 20 times 3 is 60. Okay. In the denominator, we have 2 times 5, just 10. Okay. Now there's still a little bit more cleanup we can do. We got 2 plus or minus. Okay. 4 take away 60 is -56, and that actually is going to cause a little bit of a problem here in a moment. Okay. Square root of a negative number. Okay, let's think about that for a second. Is that possible? It is. Okay, it is. Okay, the problem is when we take a square root of a number, what are we actually looking for? Something times itself that equals that number, right? If it said square root of 25, we're looking for a number times itself that equals 25, which would be 5. Easy enough. Okay. The problem is if you take a number and multiply it times itself, you always end up with a positive, right? Because whether it's a positive times a positive, you end up with a positive, or if it's a negative times a negative, you end up with a positive. So the answer, or the question I've got is, what number can we multiply by itself and end up with a negative value? No matter what, we should always get a positive value when we do a number times itself. Okay, and this is a little bit of a different situation, and I'm not going to go deep into detail with it, okay, but this actually has an explanation, okay, and I'm going to jump forward here for just a second. Okay, we've seen solutions, root zeros occur when the graph hits the x-axis. That's what we've been looking at. Roots, zeros, solutions occur when a graph hits the x-axis, okay, but we've also seen parabolas that will like start above the x-axis and then take off going upwards. Well, if that's the case, they're not going to hit the x-axis. Or maybe they start off below the x-axis and they turn downward. They're not going to hit the x-axis. So what does this mean? Does it mean that there is no solution? If the solutions exist on the x-axis, what happens if the graph is never on the x-axis? Does that mean that there are no solutions, that there's no values that'll work this equation? Okay, and it's a good question, kind of a tough question, but it is a good one. There are still values that work. Okay, there are still values that work, but they don't exist where we expect them to exist. They're supposed to be on the x-axis, but they're not. Okay, and this is, whether you realize it or not, the higher up you get in mathematics, you're going to find out that sometimes things don't exactly work the way we expect them to work. Our understandings of mathematics, you would think that by now we would know it all, but we don't. Okay, there are some things that just do not have, we don't have a real good grasp on how stuff is trying to work. This is one of those cases. If solutions are supposed to be on the x-axis, then how come we find some sometimes that are not on the x-axis? Okay, and the term they've assigned to this is imaginary. Okay, and if you've never heard that term before, you may want to jot it down. Okay, imaginary solutions are when solutions exist somewhere other than on the x-axis. Okay, imaginary solutions exist somewhere other than on the x-axis. Now, what would have to happen inside of an equation in order to end up with a solution that's not on the x-axis, like an imaginary number? Well, this is what has to happen. When we end up with a negative underneath a radical when we're trying to solve, okay, we're going to get a number. This thing is going to give us a number, but it's going to give us a number that we don't understand because we expect anything coming out of a radical to be a positive value. That's going to force it to be negative. And the way we understand mathematics, there shouldn't be a negative coming out of underneath a radical. Okay, so it's kind of like one of those things where the high-powered mathematicians of the world have said, hey, we know the way math works, or we know the way we think math works, and this isn't working out right. We understand that it's not working out right. We haven't figured it out yet, so we're just going to give it a name. And the name is imaginary solutions. Okay. Now let me show you what your calculator is going to do if you ever happen to bump into this. Okay. We're going to do the same thing we did just a moment ago. We're going to type this thing up. 2 minus the square root of negative 56. That's in the numerator. Actually, I meant to put in a parenthesis in the front, so I'm going to insert a parenthesis there. Whoa, that was, I'm not real sure what my calculator's doing there, so I'm going to see if I can't get it to stop. There we go. Parenthesis 2 minus square root of negative 56. Okay, that's in our numerator, and in our denominator, we have a 10. Well, our calculator is bound to the same understanding that we are. Okay, the calculator believes that there should not be a negative underneath a radical, just like we believe there should not be a negative underneath a radical. So when we ask our calculator to solve this, we're going to get an error message. Okay, and basically it's complaining that we've got an unreal answer. Okay, it doesn't know how to deal with that negative underneath the radical. If this ever happens to you, let me show you how to fix it. Okay, just quit out of that. Go back into the mode. We've learned that we can change some of the things in the mode. Okay, and one of the settings that your calculator automatically sets itself at, down here at the bottom, you see where it says real? Okay, that's what the calculator's complaining about. Right now it's looking for real solutions. Okay, which is good. Real solutions are good. But it's not the only type of solution that's out there. We are dealing with a non-real solution right now. And what you can do is you can come down to real and you can move it over to the next entry. Okay, that one that says A plus BI. Okay, that is the format for an imaginary solution. Okay, quit back out of that. Let's try that entry again. And look, we get a number that goes along with this thing. Okay, the solution is this value, get a little space down here, x equals 0.2 minus 0.74, and I is the little guy that shows up on that. That's basically announcing that, hey, something went wrong in the answer, and part of the value went imaginary. That's what the little I is for. Okay, and you'll work with him more in Algebra 2. Okay, but there it is. Okay, just reading it right out of the calculator screen. 0.2 minus 0.74, 0.75, whatever, and I is part of the answer. So you'd write him down also if you ever see this. Okay, and we can do this again for the other side of the problem. Okay, we've got, change this to plus for the other side of the plus and minus in the numerator. Okay, and we're going to get another imaginary answer. And in this case, all it did was change the sign. 0.2 plus 0.74, 0.75 I. That doesn't happen too much. I wouldn't expect to see that, on your assignment tonight. There might be one that tries to do it. Okay, I haven't worked the problems out yet. Okay, but if it does happen, okay, whether it be on an assignment or an end of course test or a semester test or whatever, okay, just realize that yes, from time to time we are going to end up with some negative values underneath this radical, and all it means is instead of real solutions like we got on this first example where it was just numbers, okay, it is possible that we may end up with imaginary solutions. And we'll spend a little bit more time in the coming days talking about what that actually means, how that happens, what to do about it, when you can expect to see that, stuff like that. Okay. But anyway, that's pretty much the way this works. I just wanted to show you a couple of examples. The only thing that's going to make you any better at working with the quadratic formula is writing it down and plugging numbers into it for yourself. Okay, so that's what we're starting to work with today. We're going to work on it for the next few days, so we should get plenty familiar with it before it's all said and done.